Hello and welcome to today's discussion. Northern Mindanao is situated in the southern region.
Before we can start presenting our insights, first, we will be introducing the tools and processes done for us to come up with our observation. First is we use datasets from USGS Earth Explorer of 2014, 2019, and 2024 Landsat 8 map of Upper Northern Mindanao, alongside with other shapefiles such as Philippine Administrative Map and the Roads and Building dataset from the Humanitarian OpenStreetMap team via the Humanitarian Data Exchange. The roads and buildings will be used as factors in determining land use change. Next is for analysis. We use the latest release of QGIS for geospatial analysis, alongside with SCP for layer pre-processing and classification. We use MOLAS for use in predicting land use change scenarios, alongside with GDAL for pre-processing necessary, for example, vector data to raster data. Next is let us provide our observations. In a span of 10 years, we had observed some significant changes. But for this case, we will observe some changes in the interval of 5 years. We notice that land use do have an observable increase indicated by the light orange color in the map. Next is most developments mostly reside in the edges of the region. For the case of classification, we had observed 87.81 accuracy for 2024, 89.15 in 2019, and 87.70 in 2014. Followed that is a Kapahat classification observed in the span of these years, and we can imply that the classification is accurate with good training and validation results. Challenges observed is classifying used land in the datasets can be a hit or miss and prone to misclassification errors, and cloud covers are affecting the quality of classification. And interestingly, using MOLAS, we had observed interesting changes such as decrease in vegetation and used land. The decrease in vegetation might be associated with certain urban developments, while used land only has some decrease, implying reclamation efforts or misclassification errors associated by noise such as clouds. After we had processed our transition map via MOLAS, we had tested the learning performance of the model using 1,000 random samples, implying a noisy observation where validation spikes throughout the training, implying overfitting. It also performed well when presented with unseen data and a kappa score of 0.32. It is quite unreliable. Lastly is performing predictions using the cellular automata simulation. Using the road and buildings dataset as spatial variables, we notice a drastic increase in land use. Notice that Cagayan de Oro will face significant increase in land use, especially in some few cities such as Iligan. The Lana del Norte region may face land use increase alongside with some areas in Misamis Occidental. We may also have noisy observations including misclassification due to clouds. Therefore, we may predict that increase in land use might happen 10 years later due to increasing productivity in the region. And now, let us move forward in this segment.
Before reaching this conclusion, let's explore the underlying perspective that shaped this discussion. We have Upper Northern Mindanao that will face significant land use increase in 2034. There are certain losses in vegetation in a span of 10 years from 2014 until now, 2024. It is best recommended to improve sampling quality, such as high-resolution data, more samples for collection, and collecting maps with little to no cloud cover. And lastly, mapping the whole Northern Mindanao will be considered for future analysis. In conclusion, addressing the projected land use increases and vegetation losses in Upper Northern Mindanao requires improved data quality and sampling methods, while expanding mapping efforts to encompass the entire region will provide a more comprehensive foundation for future environmental and developmental planning.